Hello everyone, this is Super CEO again. So this is your third video, or video number 3 on continuous variable or continuous distributions questions on Cambridge textbook. So today, like I said, we're going to move on to the development part of section 16B in extension 1 textbook, or 10B in 2-unit or advanced mathematics course for E12. So the questions are like this. So we're going to focus on this video, question 8 and question 9, as you see right there on the screen. Okay. All right. So question 8. Actually, before we do that, I forgot to chuck this in. Again, the disclaimer. Righto. Okay. So question 8. First part of the question is this. So the frequency function, or the little fx, is given as y equals 2x with the domain of 0 to 1, and it's given as a PDF. Right, so rewriting that, and part A, where you have to sketch this little f of x function, or the frequency function. I call it the frequency function. Okay, so straight line going through the origin with the gradient of 2. So there you go, starting at 0 and finish at x equals 1. Nice little sketch there. And part B, you have to actually find the shaded area and also compare that with the actual definite integral, and which should be the same. Let's see if that's the case. The shaded area, well, it's the triangle, so it's half times base times height, so that's nicely 1. And the actual integral also gives you 1 as the answer, so as expected. Part C, so part 1 is to show that within this triangle graph, you have to now put the x as a value between any value between 0 and 1. So therefore, its corresponding y value is 2x. So notice again, x is any value between 0 and 1. So that's a one possibility. Okay. So what it does is then this area under the curve, in this case the straight line, will basically be your CDF. So your CDF then will be, that's the CDF in probability notation. Big X is the continuous random variable, and X is, in this case, is any value between 0 and 1. So X is one of the values in the domain between 0 and 1, and the big X is the continuous random variable. So that's important to distinguish that. So again, half times base x times the height, 2x, is x squared, which means this is now your CDF, the continuous distribution function, and which is basically what part 2 is trying to get you to do again, but in different language, in the language of the integration. Okay, so there we go. So again, this is from 0 to x, all right? This random x between any value between 0 and 1. And instead of 2x, you now have to put 2t, because t is now the third variable that you need to use for the integral definition. All right, so then this becomes t squared and evaluated from 0 to x, and that gives you x squared, which happens to be the same, which should be the case anyway. Now, finally, part D is where you have to calculate all these different quartiles. So Q2, the median, so that means when the CDF becomes half, so x squared equals half, and x equals 1 on root 2. Now, the reason I'm discarding the negative answer or negative 1 on root 2 is because negative 1 and 2 is not in the domain, which is up here. So that's why you only need to consider the positive case. So that's going to be your median. And Q1, the lower quartile is a quarter. So again, positive square root of quarter is half. So that's your lower quartile. And finally, the upper quartile is 3/4. Hence, positive square root of that is square root of 3. So that's that one. So here, I'm just saying that again, x, because of the way the domain is defined, it's only the positive value between 0 and 1. All right, next question is question 9. So this question 9 is basically where you have to find all these values for C in different parts like B, C, and D. So A is given, so the little f of x function is given as C x to the 4, and that's given as a PDF function. So that means this integral in the domain of 0 and 3 has to give you 1, and also that little frequency function, little fx, has to be greater than 0. But guess what? X to the 4 is always non-negative. So that means that leaves C has no choice but to be 0 or above. Okay, so now performing that integration will give you that. Notice C is the constant, so C on 5x to the 5, evaluated from 0 to 3 is 1, so hence now solve for C, then you get that, okay, which is 5 on 2, 43, which is positive, so that fits in nicely. Now, part B, I'm skipping it because it's exactly the same frequency function as C, but different domain. So I'm just going to showcase one because it's exactly the same, but different domain. So this time from -5 to 5, again, that has to give you 1. And also that little frequency function, which is a constant in this case, has to be greater than or equal to 0. So performing that very simple integration will give you that, and hence that one. So C has to be 1 on 10, which is positive, so that has to be the answer. Now, coming down to part D, that's where it gets really interesting. So let's see what I mean by that. So that's the integration that I need to perform between 0 and C. So the endpoint of the domain is unknown. So you've got the little fx function there. Now notice this, depending on the x value, this could be positive or negative. So we have to work out first of all what that has, in which values of x that little fx has to be positive, because it has to be one of the conditions. So if you solve that nice linear inequality, then you will see that x has to be actually less than or equal to 1. So in other words, this c value has to be less than or equal to 1. Okay. All right, so let's actually perform the second condition, that is to evaluate this integration, the definite integral. Then you get this. All right, so that's again coming down to your knowledge on integration. So you really need to stay on top of your basic integration techniques. So substituting it, then you get this, and that gives you that, and which means this quadratic equation, and make right hand side 0 and this. Now this is not monoquadratic trinomial with the left hand side equal to 0. And now I'm using cross method. If you're not familiar with that, you can use any other method like I forgot the names of those methods, but you know, that's the PSF method. I think one of the other alternatives is called the PSF method. And yeah, there are millions of different methods that you can use, but I personally like the cross method, so that's why I use that. If you have any other methods to use, then by all means use it, as long as you get the right answers, so which are these two. Now, unfortunately, only one of them in this case works. So that's going back to this part that I've talked about. We figured that x has to be less than or equal to 1. So out of half and 3 on 2, it's only half that actually makes sense. to be the answer. Now, you could also use this one. I mean, out of these two values, C values, you can actually sub back into the little fx function, which is then if you substitute half in there, then you get positive answer. But unfortunately, if you substitute 3 on 2, you don't. So that way you can see that C equals half is the only answer. So you either use this method or that method to eliminate one of these possibilities. You can do that. All right. So that about does it for this video, and I'll see you guys next time.